Hello, everyone, and welcome to the course Reasoning LLMs from Scratch. We have completed about 20 lectures right now, and we have almost reached towards the end of the second section of this course, which was focusing on pure reinforcement learning. Before we cover the last lecture in the second section, let us quickly understand what are the goals we set out with when we started this course. Remember, the objective of this course was to understand uh, how do reasoning models exactly work and how they are built. And what we saw is that there are four broad methods to build reasoning models. The first one was inference time compute scaling. Our first three lectures were dedicated to this. The next module was using pure reinforcement learning. The next 15 to 16 lectures were devoted to this method number two, in which we saw from the basics of classical RL to modern reinforcement learning, TRPO, PPO, and GRPO. But we have not made the connection between GRPO and reasoning models yet. That connection is missing from our approach right now. In today's lecture, we are going to form the bridge between GRPO and reasoning models. So, this will mark the completion of the second module, which was focused on pure reinforcement learning. Towards the end, we will also see how we can build our own reasoning model by converting a non reasoning model into a reasoning model using the GRPO technique. So, using this, we will see the power and the beauty of reinforcement learning. Okay, without wasting any time, let us quickly dive into this lecture. So, today, our primary objective is to form a connection between GRPO and reasoning models. All that we have seen in the reinforcement learning phase of this course has been finally building up towards this lecture. This connection was first established in January of 2025 when the DeepSeek R1 paper came out. This paper came out on 22nd Jan, and it completely changed the LLM development process. Uh, and then afterwards, the progress in reasoning models has been very fast. One after the other, there are more reasoning models coming out because DeepSeek R1 gave a blueprint for designing reasoning models. Okay, but before DeepSeek R1, the first model which they came out with was DeepSeek R10. Now, the interesting part of this model is that the model used GRPO as the reinforcement learning algorithm, and it did not use any supervised training examples. It will become clear in a while why that is important, but just keep that in mind that the model DeepSeek R10 used pure reinforcement learning without relying on trained input output pairs on which the model could be fine tuned. Now, the following is the GRPA process. Remember from the last lecture, we get rid of the value function model, and the LLM gives different outputs. Multiple outputs are sampled, and these outputs are used to calculate their individual rewards. And finally, the advantage is calculated from these rewards itself. We do not need a separate value function model. So, the simplicity of the GRPO process is very appealing. Now, notice that here we still have a reward model to estimate the rewards. And the question which was asked in while developing DeepSeek R10 was, can we even get rid of the reward model? We have already gotten rid of the value function model. Can we get rid of the reward model too? And the answer was yes. They got rid of the reward model by using rewards for which a model was not necessary, but which could be verified using external tools. Now, what does that mean? Imagine this example. We are giving an input, solve 5 into 3 plus 4, and our model LLM gives this answer 35. Now, to cross check whether this answer is correct or not, you don't need a reward model which is trained on input output data, but you can simply verify it through a calculator and see whether the answer is correct or not. Similar with coding examples, if you have an input which tells you to sort these numbers and you write the code, you don't need a reward model to verify whether the code is correct or not. The paper used the lead code compiler to check whether the answer is correct or not. So, using external tools, we can figure out rewards which are objective in nature, which come in specific values. There is no subjectivity to it. And we do not need to train a reward model for these data sets. Now, without the reward model, the modified GRPO process looks as follows. Now we don't even have a value function and we don't even have a reward model. So the process has gotten even more simpler by removing the need for having a separate reward model. Okay, so now this is the pipeline which was used in DeepSeek R10, but and they added one more extra element to this. Along with these accuracy rewards to check with calculator, lead code compiler, etc., they also added something called as format rewards. Now, format rewards were added to make sure that the thinking of the model uh, is enforced between the think tags. So, if a model gives an answer which does not have the think tags, uh, it was penalized. That is, it got negative rewards. So the model learned to provide answers which could fit inside these tags. So these are called as format rewards. And DeepSeek R10, the reinforcement learning algorithm, which was GRPO, the rewards were of two types: accuracy rewards, which were checked against tools which could verify these rewards, and second were format rewards. This process is also called as RLVR, which is reinforcement learning through verifiable rewards. Okay, so now after this they added one more element which was a training template. The training template reads as follows: a conversation between user and assistant. The user asks a question and the assistant solves it. The assistant first thinks about the reasoning process in the mind and then provides the user with the answer. The reasoning process and answer are enclosed within the think opening and closing tags and answer opening and closing tags, respectively. That is, think opening tag, reasoning process here, closing tag, answer opening tag, answer here, answer closing tag. So we are basically giving a training template and asking our model to follow this template while writing the answers. We are not telling it how to think, but we are giving a broader training template. We are just telling the model, okay, first think about the reasoning process in your mind and then give the user with the answer and make sure the formatting of the answer is correct. So this is the DeepSeek R10 training template. So essentially, they introduced three things. First is they got rid of the reward model. Second, they introduced format rewards, and third, they added a training template. Now, okay, at the heart of it was still the GRPO algorithm, which was used to calculate the advantages. So, what was so special about this? And it turned out that as the training advances, the reasoning capabilities of the model improve autonomously, that is, without any direct guidance. They improve by themselves. And how did the paper show that? Well, look at this graph. On the x axis, you have the training steps. So it indicates higher steps means the training has been carried out for more time. And on the y axis, you have average length per response. So the more is the length per response, the more time the model is using for thinking before it answers. What happens is that as the training progresses, the model learns to solve questions which are provided in the data set which is used to train the model by using more test time compute. That is, it thinks more before answering as the training time increases. And this is something which humans also do. If we are given a data set which has a lot of complex questions, initially we'll probably look at easy questions and try to answer fast, but eventually we have to get to answering the complex questions. And to answer the complex questions we have to think more, otherwise we will not be able to answer those questions. And this is exactly what the model figures out. It figures out that I will not be able to answer these complex questions unless I think more. I use more test time compute. And it naturally learns to solve these complex reasoning tasks in the process. And one of the famous movements while training DeepSeek R10 was they gave a question which says if A is greater than 1, then the sum of real solutions of an equation is equal to. So it's a complex question. And the model starts to think in one path, but it understands that the thinking is not correct and it says let's reevaluate this step by step to identify. So remember, in the training template we never asked the model to reevaluate its initial answers. So from where did it understand that it has to reevaluate the answers? We have not even given any supervised fine-tuned data where we have told the model this is the input, this is the output, and you have to answer like the input output pairs. If that was the case, then it was understandable because maybe in some of the input output pairs this re-evaluation was performed. But the beauty of this aha moment is that without giving any input output training examples, the model learns to reevaluate by simply uh, increasing the training time steps. As the training goes ahead and the model keeps on improving, it learns to solve these complex reasoning tasks in a way in which humans solve these tasks. We also do this sometimes, right? We start to answer something and then we realize, okay, this is not correct. Let me scrap that and let me uh, try a new approach. So GRPO allowed the model to develop these powerful reasoning behaviors. And this is the first time when people took reinforcement learning very seriously when it came to building large reasoning models. And after DeepSeek R10 came DeepSeek R1, which used other techniques which were not pure reinforcement learning. We will look at those techniques in subsequent lecture. But this lecture, I want to dedicate and demonstrate the power and the beauty of reinforcement learning. Okay, so now what we are going to do is to demonstrate this to you practically. I want all of you to understand how a non reasoning model can be converted to a reasoning model using GRPU. And I have written a Google Colab notebook, which is uh, inspired from this reinforcement learning guide from Unsloth. They have some amazing resources which I really encourage you to check out. And in one of the notebooks they had shared, uh, there is a project in which we can convert a non-reasoning model to a reasoning model using GRPO. Now, in this example, we are going to take the example of Quen 2.5, 3 billion parameter non-reasoning model, and we are going to convert that to a reasoning model. So, step number one is to install Unsloth and VLLM. Unsloth is a something like Hugging Face, but it is used for uh, faster fine tuning of of LLMs. They offer a lot of libraries which make fine tuning very efficient, and VLLM um, is a package which is used for serving LLMs for faster inference. So we need both of these in the step one. In step two, you can see here the Quen model is loaded, Quen 2.53 billion parameters. In step three, we define the training template, which I mentioned to you before. We have a reasoning, opening and closing tags, and we have answer, opening and closing tags. Then we have the training data set. We use the GSM 8K data set, which should be somewhere here. Yes, OpenAI GSM 8K data set, which has a bunch of arithmetic and logical questions. So this is the data set uh, which will be used to fine tune our model using reinforcement learning. Basically, what we'll do is we will feed a lot of these questions from this data set to our model, and then we will generate rewards, accuracy and format rewards, which I will explain later. And then this will be used to fine tune the model using GRPO. Now, to understand whether the answer is correct or not, we need to define reward functions which calculate the accuracy and the format reward, which is exactly what is done next. So, this is the function we write for calculating the accuracy reward, the format reward, and this is the function we write for calculating the accuracy reward. After both these functions are written, we can set up our GRPO trainer uh, using this function, and then after setting up the trainer we can basically start our training process. I used an A100 GPU uh, in the Google Colab itself. I had purchased it. Otherwise you can use a T4 GPU as well, but it will take significant more time. For me the training took multiple hours, 3 to 4 hours, and then the training was completed. But this is the most time consuming step in this whole process. Now let's come to the exciting part. What do you see as the answer? First, we test without any GRPO fine tuning. And if we ask this question, how many R's are there in strawberry? It says there are two R's in the word strawberry, whereas we know that the answer is three. So this is a classic failure case of non-reasoning LLMs. But now using GRPO, we give reasoning powers to the LLMs, and with the same question it answers. To find out how many times the letters R appears in the word strawberry, we can go through the word character by character and count each occurrence of R. In strawberry, the letter R appears three times, once in the beginning, once in the middle, and once at the end of the word. This is absolutely amazing, and it really blew my mind because with RL training suddenly becoming accessible to us, uh, it allows us to see how training with GRPO can teach reasoning to a large language model without explicitly giving any input output pairs of data. So you can clearly see that the model has learned to reason properly. This is similar to how we think when we are asked questions like these, but of course, our thinking happens very fast. But if you break down the thinking steps, they look kind of similar. The Google Colab notebook looks something like this, where the individual snippets I have shown you, but it's not a very complicated notebook, and I think Unsloth have done a brilliant job of making these modules accessible to everyone. Okay, so this brings us to the end of this lecture and this section also of the course Reasoning LLMs from Scratch. Uh, in this entire phase, we have covered the basics of reinforcement learning. It was designed to be understood by people who are complete beginners in the field so that they really grasp whatever I'm showing right now. There is a lot of history behind it, and I didn't want to show you this directly without helping you appreciate the deep history which has existed before uh, the large reasoning models which we are seeing right now. So, with this, we have completed two sections. The first is inference test time compute, and the second is pure reinforcement learning. Now, the last two sections, which are remaining, are supervised fine tuning and reinforcement learning, and pure supervised fine tuning and distillation. Again, these methods were made popular by the DeepSeek R1 paper itself, but we will take some time to explain this in subsequent lectures. Thank you very much, everyone. And I really want you to run these notebooks by yourself. There is a lot of satisfaction we get by seeing reasoning develop in a large language model. Thanks.